Now, the entire solution that we've seen up to this point has been predicated on the idea that y is less than L. And we ask, what if y is greater than L? Well, if y is greater than L, let's go back a second to the point where we separated the variables, applied integration by parts, and came up with our solution. Y over absolute value of y over L minus y was equal to AE to the KLT. Now, at this point we applied the fact that y was less than L, or the assumption that y was less than L, to this absolute value. If y is less than L, the denominator is going to be positive, so y being positive makes this expression positive, so the absolute value of this expression is just this expression. We got this expression equal to AE to the KLT and proceeded accordingly. Now, if y is greater than L, that implies that L minus y is negative, which implies that this entire expression is negative, so that the absolute value of y over L minus y is equal to negative of y over L minus y. In this case, the solution to our equation becomes, well, the next step in the solution would be negative y over L minus y equals A e to the KLT. Changing the sign, the negative can appear over here, so that y over L minus y, where these are parentheses now and not absolute value signs, is equal to this. Now, we can go through the details of solving this equation for y, and I'll go through those very quickly. We multiply both sides by L minus y, obtaining y equals negative A e to the KLT times L minus y, which is going to equal then negative A L e to the KLT plus A y e to the KLT. Rearranging the equation so that the y's are all on the left side, and factoring out a y, we get then y equals 1 minus A e to the KLT equals negative A L e to the KLT, so that y equals negative A L e to the KLT over 1 minus A e to the KLT. If we factor out an L and reverse the signs in the denominator to compensate for the negative sign here, we end up with L multiplied by A e to the KLT over A e to the KLT minus 1, and then dividing through by A e to the KLT, we end up with y equals L times 1 divided by 1 minus 1 over A e to the negative KLT. Multiplying numerator and denominator by I, we can end up with L times A over A minus e to the negative KLT, and I started putting a negative in front of the KLT here because I wasn't paying much attention, and that's e to the KLT, not e to the negative KLT. Now, and I'm sorry, that was e to the negative KLT, so I thought I'd made a mistake and hadn't. I was looking at something else apparently. So anyhow, we end up with the form then, y equals L times A over A minus e to the negative KLT. This is just like the form that we got originally except we have a minus here where we had a plus before. The implication here is that since e to the negative klt is positive, that makes the denominator here less than a, which means that y is going to be greater than L. So that if y is greater than L, as we assumed, y stays greater than L. So a minus e to the negative klt is less than a, so L times a over a minus e to the negative klt is greater than L. So y equals this, remains greater than L. However, as t approaches 0, this term approaches 0, so that the denominator just approaches a, and y, as previously, approaches a limiting value of L. The corresponding equation, without elaborating, you will be asked to work out some details with similar equations. We have our limiting value L, and y is greater than L. So our original value y is greater than L, meaning that y starts up here someplace and exponentially declines toward L. This incidentally is consistent with what we would get if we were to do a direction field. The directions are increasing but approaching horizontal as we come up from the bottom. Our slopes, our directions, will be negative and approaching 0 as we move down toward L from above.